Okay, girls, so this is the second video in the sorting for this weekend. This one is called the insertion sort. If you haven't watched the selection sort, which was the first one, you should go back and watch that first because that has kind of an intro slide to talk about the different sorting algorithms that we'll be looking at. But this is the second one. What we're going to do here is I'm going to show you how it operates using a semi-sorted list, and then we're going to take an unsorted list and do it from the beginning to the end. So there's kind of two parts to this. But to understand how it operates, it's useful to do this one to start off with. So an insertion sort is an algorithm which uses a similar approach to sorting, say, a deck of cards where you have two cards, you pull them out, you don't know what they're going to be, and when you get them, you look at them and you say, okay, that's 7 and 9, so 7 goes first, then 9, then you take another two, you look at them and you decide, okay, you've 3, so where does that go? It goes in front of 7, you insert it there, and then the next one. So it works a bit like that. We're going to step through it anyway. So what it does is it works by iterating or looping through the sorted items in a list to find out the correct location at which to insert the new items or the current items. So we're going to take a look at an example. And what we're going to do is use similar colors to what we used before. So we're going to say yellow is the sorted part of the list and our blue is our current item. So we're saying that we're in the process here of sorting this list. It's not starting at the very beginning. So the yellow section is already sorted. The blue item is the next one to be examined in the list. So what the algorithm does is it takes our next item or the item we're currently looking at, which is this one here, number 17, and it keeps iterating left, so in this direction, so moving left, until it finds its ordered position in the list. In this example, the ordered position is going to be the first one. And that's really easy for us to see as humans because when we look at this list here, we see the entire list and we can determine where 17 fits in that list of items very easily and very quickly. But computers are not humans, so they cannot see the full list the way we do as humans. So the algorithm keeps shifting the sorted items up the list towards the right, while the larger items are moved to the right to make space. So we're going to see this now in the example. So for example, if I was to say, we're still here at 17, which is the item, the current item, the one we're looking at, and this is our sorted section here. What's happening is 17 is iterating towards the left. And as it's iterating towards the left, it will go through each of these to get to the position it needs to be in. But as it's iterating to the left, so if we look at it here, this is our current one, and it's partially sorted. So what we see is that one part of the sorted list is to the right, and the other part of the sorted list is to the left. Is not completed, it's just in progress. So what has happened is these two items have moved down because 17 is less than 85, it's less than 63, and we haven't got to these yet. So it's about to do the comparisons on those two. And the same thing will happen. 17 will be compared to 45 and it will insert in there because it will know that 17 is less than 45. And then it will compare 17 to 24 and it will insert 17 into the 24 position and it will move the other sorted ones down to the right. So these will eventually move in this direction as well. And that's how it works. So from there, we are going to work through an entire unsorted set of items right down to having them fully sorted. Okay, so I've just shifted the screen over. So what you're seeing is the list at the top, 85, 24, 63, 45, 17, 31, 96, 50. That's the unsorted list. And each one underneath is at each step of the sorting process. I'm going to talk you through it, but it just saves me having to scribble the writing. In the last one, I did something similar, but I wrote it underneath when I did the selection sort. This might be just a little bit neater for you to follow. So let's go from the beginning. So 85, we're making kind of an assumption here that this is sorted, which is maybe a little bit of a leap. but it's the sorted end of the list, if you want to put it that way. And then this is the item that we are trying to sort, or the current item. So this is like your current item or the item you're trying to sort in the list. So when we have two items like this, we have to determine whether they need to be swapped, and that's just done by comparing them. So is 24 less than 85? Yes, it is. So we swap them, and that's the first step in this. The two items are then swapped. So we have 24. So we do a swap. Swap is probably a bad term. In fact, we say that 24 is less than 85, and we insert 24 ahead of 85. Rather than saying it's a swap, because it's an insertion sort. So we do an insert ahead. Sorry, my writing is terrible. Ahead of 85. So what we end up with then is our sorted part of the list is here, 24 and 85. And then we have our current item, which we are going to compare. Our check is 63. So if we look at 63, then it is going to iterate. Remember, it's going to iterate back towards the left. And in fact, 63 will insert in between 24 and 85, giving us the next sorted part of the list like that, with our current, let me get my blue, number to be considered as 45. 45, then it's the same thing. That's going to iterate back through, and it's going to insert in between 24 and 63, giving us a new sorted list that looks like this, and a new current item to consider that is this. And this was where we started with the example that we had. So the insertion is happening. Maybe I should write that in just so as you have it. Oh, anytime I try and do anything fancy, hang on. Let's pull this down a little bit. So in here, we are saying 63 inserts between 24 and 85. 45 inserts between 24 and 63. Now, how is it doing that? I'm just saying it's inserting, but remember, it's doing a comparison, and I'm going to talk a little bit more about that now in the next step. So we're at 17. So 17 is going to insert in, 17 is going to insert before 24. And why it does that, I'll talk about it again. It looks at 17 and says, is that less than 85? And it is. So it moves one space to the left, and 85 moves one space to the right. So it goes 24, 45, 60, 17, 85. Even though we don't see that, it just happens in the background in the processing. 17 then is compared to 63, it's less than that. So it goes in there and everything shifts this way. 17 is less than 45, it shifts this way. 17 less than 24, it goes in here and everything shifts that way. And that is what we did over here a second ago. That's what we were talking about there. We took that example and we stepped through how it ended up over here at the end. So I'm not doing that for each of those steps here, but that's how it's happening. It's checking, it's comparing if it's greater or less than, and whether something needs to be moved or not. So the next one then, we end up with 17 at the start. So our sorted list, sorry, is here, and the current item that we are looking at is 31. Okay, so 31 then has to be inserted, and that is going to go in, oh, let me not mess with my colors, and that is going to go in between 24 and 45, and it's going to be determined based on the greater than or less than. Is it greater than or less than? And then we have our sorted list as far as 85. We have the item that we are considering, which is 96. Now, this is an unusual situation in that it will do the comparison, but it doesn't insert anywhere, because 96 is greater than all of the other numbers here. So there isn't actually an insert, or it does not do an insert on this iteration of the the sorting loop. It's not going to do anything. It will do all the comparisons, but it doesn't actually make a change. And because it determines that 96 is sorted and in the correct position in the sorted part of the list, which it is. And then we finally end up with the value of 50, which is our current one, and that will insert into the list between 45 and 63. And then we have our sorted lists, which is here. I did put it in. I was thinking, oh no, I don't have it. So this is our sorted list. Let me get rid of that. Sorted list. So it's really important to me that the logic of what's happening, the steps, is understandable by you. So in the last video, I asked you to think about those steps and how you might write an algorithm for those steps. I don't want code. We will do code on Monday, so don't worry about code. I know the temptation might be to write code if code is where you're comfortable. I don't want you to write code. I want you to try and tell me the steps that are involved. Even if you just write out step one, compares, does greater than, moves, whatever, as I've described it, and condense it into a set of steps. I will do the code with you then on Monday, and that's enough for the weekend. If you have time and you're not really getting this, maybe have a second look at each video, but that's only if you have time. I don't expect you to. We can talk about it on Monday. I'm going to bring worksheets on Monday that will get you practicing um, implementing the algorithm without writing code, and then testing your knowledge around it. And then the very last thing we're going to do on Friday or on Monday is write the code for this, because the code follows from your understanding. If I showed you the code first, it's very difficult to follow, but you have to understand this first. I hope it helps. If you're watching the videos over the weekend and you have burning questions, please email me. I'll be checking my email over the weekend and I'm happy to reply to anyone. So don't be afraid to do that. I'm more than happy to take email questions at any stage. So if you've gone through this and you have questions or something is confusing you, please just email me and I will come back to you on it before Monday. I won't be going through these illustrations on Monday. I'm expecting you to have it done. I will have exercises on these for you to do, and then I will be going through the code. And then for Thursday, I'll provide your homework will be new videos to watch before I see you again, and then that'll be the next two sorting algorithms, and then we'll go to those in the next double class as well. So hopefully by the end of this week we'll have sorting more or less finished for you guys. One other thing that occurs to me, or two things, sorry, is I'm not sure where you are with lists. So coding with lists in Python, if you've done that or not. I'm hoping that you have, because having to go back to that might take a bit of time. And then the other thing is the selection sort uses min. It checks if the min in it, it has to find the minimum number in the unsorted list. So it uses the function min. I'm not sure if you're familiar with that or not. So I'm happy to go back over that. I will go over that in class with you, but I'm just hoping that you're okay with lists. If it's a long time since you've done lists, it's worth just looking at that again before Monday, because it's kind of an assumption that you're going to be able to follow that. Okay, that's great, girls. Have a lovely weekend. I hope this wasn't too difficult for you, and I'll see you all on Monday.